All right, hello and welcome to another video of the MSU Denver video walkthrough of the Elementary Calculation Study Guide. In this video, we're going to be talking about graphing inequalities. And if you've watched any of the other previous videos, then you may be a little concerned about the fact that there's already a bunch of writing down. But the reason that there is, if you've watched the previous video, you'll know what this is all from. But the previous video was graphing linear equations, and the reason I left all the information, including all of our practice problems, was that the difference between graphing inequalities and graphing linear equations is quite small. There's a few details, including shading, which we'll get into. But in particular, the practice problems for graphing inequalities are the exact same practice problems for graphing linear equations. It's just they turn them into inequalities. And so I left those up, and we'll turn them into inequalities, and we'll kind of finish what we started. But if you're not familiar with inequalities, please, we have a video on inequalities, so please go watch those. And if you're not familiar with graphing linear equations, please go watch that, because we're just going to kind of jump into the graphing of the inequalities. And so I'm going to scroll down right to number 1, and we're going to just kind of jump into it. And they're already done. If you're not familiar, like I said, if you're not familiar with the graphing of the linear equations, please watch the previous video. This is where we did all that. But before we just jump into that, I'm going to talk just a few things. Inequalities, there's basically 4 kinds of inequalities. You have greater than or equal to, greater than, less than or equal to, and less than. And then there's also, does not equal, but we're not going to be talking about that. We're just talking about these 4. And there's 2 big things with the graphing. One is what your line looks like, and the other one is where do you shade. And so as far as what your line looks like, you have 2 choices. It's going to be either solid or dashed. And it's going to be solid if you have a or equal to in your inequality, right? So greater than or equal to, or less than or equal to, because what they're saying is everything greater than this equation or equal to it, right? And if I say or equals to, that means I want you to include the line, and so we put a solid line in there, or less than or equal to. And if it's just greater than, or just less than, then what they're saying is, everything greater than this line and not equal to, right? So they don't say that, but it's really or and not equal to. And so by saying that, or really not saying that, what I'm saying is I want the line to be there as a boundary, but don't include it in our values. And so the way we represent that is because really you can get infinitesimally close to that line, but not touching that line. And the way we represent that is by a dashed line. So you want to, it's just treat these graphing inequalities just like you would treat graphing a linear equation. But when it's time to actually connect the dots and draw your line, ask yourself, is it solid or dashed? And that's pretty simple. In fact, all of the practice problems that we're going to be doing in this video are actually just going to be solid, and that kind of sucks because I'm not going to be able to show you a dashed line. But if you look at number 2, which you should be doing on your own anyway, it actually is y less than something. And so that less than, it just means it's going to be a dashed line, right? And so that's the what does the line look like? What is, is it solid or dashed? And the other big part, the difference, in the inequalities is where do I shade, right? Because that's the whole point of doing this is it's shading a region, because we're talking about groups of numbers, right? If I say like x is, or y is greater than 2x plus 2 or whatever, I'm talking about everything that's greater than that line, right? So how do I represent that? Well, I shade. But and sometimes it's kind of easy to kind of look at the graph and look at the equation and say, oh, greater than, so it's going to be everything up here. But there's a way to actually kind of mathematically figure out where you're going to graph, and so we're going to do that. And so we look at the first problem, and they actually changed y equals x to y is less than or equal to x, so they changed it to an inequality. And so my line's going to be solid, so that's pretty simple. And then I asked myself, well, okay, I got the line, it's the same graph, right, as the previous video. Where do I shade? And so typically, and you can't do it, and that's actually good about this problem, is that you can't do it in this problem, but typically you're going to choose a point. And again, typically, I keep saying that, you want it to be 0, 0, the point to be 0, 0, because that makes everything easier. You're going to plug 0, 0 into your equation. But you can't use 0, 0 if our line goes through that point, right? So you can't use any point that our line goes through. And so if we look over here at our graph, our line actually goes through the origin 0, 0, so we can't use it. And so if it does that, if it goes through the origin and you can't use 0, 0, then just pick another point. And so I'm going to pick a point like, right here. Just pick a point that's close by with whole numbers. And that point, is where x is still 0, but y is 1. And so then I just plug that into my equation. So I say, well, y is 1, and I said less than or equal to and then x is 0, so 0. And typically you're going to have to solve a little bit. For this one, it's just you plug in the numbers and there it is. But you're going to get to something like this, right? And then you're going to ask yourself, does that make sense, right? I'm telling you right now, 0 is less than or equal to, no, I'm saying 1 is less than or equal to 0. Does that make sense? It doesn't, right? And so if it doesn't make sense, then you're going to shade the opposite side. So this one, I chose a line over here. On this side of the line, it doesn't make sense, so I'm going to shade over here. So this is what my graph looks like, when I shade it in. If I chose a line over here, a point over here, somewhere like over here, and I plugged that in, I would get something like 0 is less than 5. And like, oh, 0 is less than 5. Okay, that makes sense. And so if it makes sense, if it's true, you shade that side. If it doesn't, you go to the other side of the line, right? Because a line, it's like a boundary. There's only two sides to a line, right? And so it's one side or the other, and you just say it doesn't make sense or does it not. Okay, so and that's it, right? You can shade however prettily you want. I was never staying inside the lines as a child, when I was coloring. But really, you're comparing this to A, B, C, or D, right? To multiple choices. So again, it doesn't have to look pretty. If you want it to look pretty, by all means. But jumping into number 5, again, I'll let you guys do number 2, 3, and 4. Number 5, and I plotted number 5 and number 6 on the same graph. So if you didn't watch the previous video, this line right here, I'll kind of circle it right now. It represents number 5, x equals 5. And if you're not familiar with how to do that, it's a vertical line, but please watch the other video if you're not familiar with how to do that. But they changed that. Instead of x equals 5, they're saying x is greater than or equal to 5. Now, if you kind of just think about, well, it's greater than or equal to 5, you're probably going to realize you're going to want to shade this side, right? But again, mathematically, we're going to choose a point. The line does not go through 0, 0, so I can choose 0, 0. So I put in 0 for y. Well, there's not a y on there, so I'm not going to do anything. And I put in 0 for x, so I say 0 is greater than or equal to 5. Again, that does not make any sense, so I'm going to shade the other side. And if 0, 0 is over here, then the other side would be over here, and so I kind of shade it like that. And so that's what it would look like. Again, not super pretty, but number 6, if you can see that over here, it says y is less than, y is equal to negative 2.5. That was the previous section. And that's the horizontal line that you see down there, this line right here, at negative 2.5, right? So it's horizontal, and so that's, again, if you're not comfortable graphing that, please watch the other video. I can choose 0, 0 because it's not on the line. Then I would say 0, oh, let me change the equation first. They're having it as y is greater than or equal to negative 2.5. And so I can choose 0, 0, and I say 0 greater than or equal to negative 2.5, and that is true, right? Because because negative 2.5 is a negative number, right? 0 is greater than a negative number, and so that's true. So I'm going to shade over here, right? And for this test, and I'm not trying to shove too much at you, but for this test, that's all it is, right? And again, you're only going to have one line on the graph, but if you get into algebra or something, or some business classes, you might have more than one line, and they might have to say graph all of these inequalities on one graph. And the reason they do that is because they want to say, well, where do all these inequalities, where do they share points, right? And so if I look over here, if I'm shading all this for number 6, and I shaded all this for number 5, and then this would continue over, then I don't even know how to, but all of this over here is where they're both shaded. So that is where they would kind of both be true. And you use that a little bit later on in algebra and finance classes. But for this test, for this study guide, you're only going to have one line. I just graphed them both because they were just kind of simple graphs. Moving on to number 7. Number 7, it was a little bit difficult. Again, if you want to see how we did it, well, there it is right there. But if you want me to talk you through it, it's going to be in the previous video. It's going to be solid, right? Because if I change this, it's x plus 6y less than or equal to 7, and so if there's or equal to, so it's going to be solid. Excuse me. I'm going to go over to where I actually solved for y. So I'm going to look at this here, and for when I choose like where am I going to shade, right? And again, that means I have to change this equal sign to a less than or equal to. Remember, again, we went over this in the video about inequalities, but if you ever multiply or divide by a negative, you got to flip the inequality sign. We didn't do that in this case. But so it's less than or equal to y is less than or equal to negative 1/6 x plus 7/6. You could say, well, it's less than, so I'm probably going to shade down here. But again, mathematically, 0, 0 is not, so I'm going to choose not on the line. I'm going to choose that. And when I plug in, I say 0 less than or equal to negative 1/6 times 0 plus 7/6. 0, well, this becomes, the times 0, that's going to be 0, and that's why I like to choose 0, 0, because a lot of stuff cancels out. 0 is less than or equal to 7/6, and that's actually true, right? 7/6 is a little bit more than 1, and so 0 is less than 1, or equal to, but it's less than, and so that's true, so this is over here, so that means I'm going to shade this side of the line, which is kind of what we guessed before. And, if you can see it, if you can kind of like tell, well, that's good, but choosing a point and plugging it in is the more sound way to do it. You're going to be positive, because a lot of times, especially when you have non-linear equations, it's going to be a little bit more difficult to kind of tell where you're going to shade and where you're not going to shade. But these are all going to be linear equations, so if you feel comfortable doing that, that's fine. And that's it, right? Again, watch the previous video if you need to, but the only changes here are, is the line solid or dashed? In our cases, unfortunately, they were all solid, so we didn't get to change anything. But then, picking where you're going to shade, right? And it doesn't have to be super pretty as long as it's accurate, because you're just comparing your graph to the multiple choices, right? And so those multiple choices are all going to be shaded, and they're going to be shaded probably in different areas, or maybe they're going to even be different lines, but which one matches yours, and then you pick A, B, C, or D. And that's it, right? So this was a really short video, just kind of telling you how to manipulate the previous examples, the previous video, into inequalities, okay? If you're having any concerns, any questions, maybe on 2, 3, or 4, please come into the tutoring center. See you later.